there are certain theorems that says the normal distribution is something that kind of has a natural sense. For example, for any large sample, the distribution of the sample mean is very close to normal distribution. Let's say if I were to take samples of 1 million from a population, calculate its mean, and repeat this process very large times, and looked at the distribution of those means, it's going to be very close to normal distribution. And that's called the central limit theorem. And in nature, when we model uncertainty of things, there are many things that we're not modeling. Okay? Let's say I'm trying to get a probable distribution about the rainfall in a certain area, right? There are millions of things that I either can't or don't care to factor for. And those have influences on that rainfall. But each of those influences, they're like, very small. They may or may not have normal distribution. But when you put them together, it acts like the average of those influences. That's why in most natural sciences, nobody ever looks at anything other than normal distribution. But in social sciences, that's a different thing. Especially in finance, having a return data that is normally distributed is a rarity. You have a better luck finding a dinosaur fossil in your backyard than finding a normally distributed return data in financial markets, or even close to being normally distributed. But that's what's being used, and it also kind of derives a lot of risk measures that people use in the industry. And we're going to talk about more. We're going to talk more about those, but one of those risk measures is VAR, value at risk. Okay? And typically, let's say I have a long position, which means I bought things. Short position means I sold things or I bet that they're going to go down. I have a long position, and the portfolio has a mean of, let's say, 3% and a portfolio return, and a standard deviation of, let's say, 1.5%. Okay? The so-called 95 percentile VAR is about, and let's call this mean, let's call this sigma. It's about mean minus 2 sigma. Okay? So that's going to be 3% minus, actually, let's make this a little bit more. Typically, it's not that small. Let's make it 2.5%. 3% minus 5%, negative 2%. So if you get $1 million invested into this asset, 2% of that is $20,000. So your value at risk is $20,000. But unfortunately, this 2 kind of refers to the 95th or the 5th percentile of plus or minus a normal distribution. But in real life stock return data, that is an underestimate. Okay, especially the left tail is a lot fatter. That means if you determine your trading limits and position limits based on a VAR that is obtained assuming a normal distribution, you're going to seriously underestimate your risk. That actually kind of happened in 2008. A lot of models. I mean, JP Morgan had a big model called risk metrics, I think. It all worked under the assumption of normality. You know, the math behind it, especially for derivative securities, is beautiful and tractable. So, you know, people don't think about it, especially for derivative securities. There are only a handful of people in those companies that actually can price them because most of those require numerical solution of partial differential equations. And they actually hire physics and math PhDs to do those. But the guys who are trading or the guys who are managing the risk have no concept. They always just, act under the assumption, oh, model says that this is our risk. That's it. In a sense, you know, if you're running a trading floor and your risk model, the company risk model, says your risk is 20,000, you're fine as far as the compliance is concerned. Okay, nobody can sue you because the back office people are going to look at he's within his limits, done. But they're actually risking a lot more. If you want to know a little bit more about that, there is a movie. I don't know if it's available on Prime. I think it is. It's called Margin Call. Okay, it has a lot of famous people. It has Stanley Tucci, the guy who played the Spock in the new Star Trek, Zachary Quinto. Who else? Kevin Spacey, Jeremy Irons. I think they also have Debbie Moore, but I'm not sure. But check out the movie. They don't mention which company did this, but it's probably Goldman Sachs because I know about their ethics when they're treating their clients. The company's first clients are later in Goldman Sachs company culture. One of their physics and math PhD guys realized that, you know, these distributions are wrong, okay? We're taking a lot more risk than we think we are. And in the middle of the night, he convinces one of the executives and he brings everybody to the company and they do an all-nighter and they decide, okay, we're gonna dump all of this to our clients and not take that loss. That's one of the reasons Goldman was one of the few companies who wasn't affected by the crash of especially mortgage-backed securities because they had dumped a lot of stuff to clients or to companies like AIG who were only too happy to provide credit default swaps for them, which is the fancy term for insurance against default. All right. But we're not going to worry too much about how it is calculated. Okay. We have a nice little function for that called stdeg. Okay. And I'm going to convert that to percent format. No, I don't want that ugly color. Yeah, this. And I'm going to make that purple. Again, you know the rule in this class. If you don't like my colors, that's a new problem. If you don't want them, save it and change the colors. Just based on this alone, it looks like, remember, WU was an ETF for Vanguard ETF for S&P 500. See, I may have forgotten what that was, but since I left a note to myself, Now I know that's the beauty of those notes. I mean, I do have freakishly good memory. I don't forget easily, but you don't build stuff based on your ability to remember stuff. I mean, you gotta build these stuffs assuming, you're close to being diagnosed with Alzheimer. That's why you don't forget. Obviously, stocks are riskier than corporate bonds. And remember, UUP was a portfolio of foreign currencies against dollars. And this portfolio we have is actually less risky than almost all of them. I mean, it's definitely less risky than IQD, okay? Of course, it doesn't make as much money in terms of return as well. The trouble with standard deviation, which was an issue with the mean, remember, mean is just the average of the numbers. It is not a robust measure. And the issue of non-robustness is even more acute here. Look at this formula. I square the deviations from the mean